This is a video on section 3.6 where we're going to deal with inequalities, both polynomial and rational inequalities. An inequality, a polynomial inequality, is just always going to take that form of f of x is less than, greater than, less than equal to, greater than equal to 0. When we want to solve a polynomial inequality, the steps that you go about doing that, first of all, get 0 on one side. So that's step 1. Step 2, set the expression equal to f of x and graph. Number 3, use your graph to determine your solutions. And here's what you're looking for. If you're being asked to find f of x equals 0, then we're looking for x-intercepts. If you're being asked for f of x is less than 0, then we want all of the places where my graph is below the x-axis. And then f of x is greater than 0 are all of the places where my graph is above the x-axis. So as you look at example number 1 here, my solutions for part A, this is what we've been doing most of the semester. So we know that here my solutions are going to be x equals -1 and x equals +3. It's just asking for the zeros, the x-intercepts, the solutions. For number 2, or I should say for letter B though, notice that we're being asked for everything greater than 0. Well, this is above the x-axis. And so when we look at what is above the x-axis, this is all of this right in here. So above the x-axis is going to begin at -1, and it's going to use all of the x values up until +3. So that's above the x-axis. For part C, notice that it says that my function is less than or equal to 0. Well, less than 0 is below, and equal to 0 are my solutions. You could say it's what's on the x-axis. So here I want everything below as well as on, everything below as well as on. So the way that we're going to write that, we'll start with, we have to write it in interval form because there's too many to list out. So we'll start with -infinity, and we're going to go from -infinity to -1. We're including -1 because we want on the x-axis. And then my graph goes above, so I don't want any of that. And it comes back around to the 3. It's on the x-axis there, so we include the 3, and we're going to go all the way to +infinity. We're using x values here, so that's why we're going from -infinity to +infinity. All right, so the second one. You can just graph these on the calculator, but on this one, a calculator is absolutely not needed. It's a lot easier. So for part A, we have here that either my two solutions, since it's already in factored form, is either going to be an x equals 0 or an x equals 1 with a multiplicity of 2. My end behavior, well, you take a look, your degree of the original equation is 3. So my end behavior is going to be a 1 up, 1 down. Since I have a negative leading coefficient, it's overall going to be downhill. My y-intercept is going to be going through 0, 0. So let's graph what we know so far. You see that I already have the x equals 0 and the x equals 1 on my graph. I'm going to start up at the top according to my end behavior, and I'm going to end down at the bottom. When I get to my first 0, this one has a multiplicity of 1. So it's just going to go, it's going to break straight through the x-axis. My next one, though, has a multiplicity of 2, so I'm going to bounce off of the x-axis, and then I'm going to end up going down. All right, so when we look at part B, our solutions here, notice that it's asking us for everything below the x-axis. Well, below the x-axis, let me get a highlighter here. Below the x-axis is going to be this piece. Let me do that with a different color highlighter, see if it'll come up. This piece here, as well as this piece here. All of this is below the x-axis. And so that's going to be from 0 to 1. and from 1 to infinity. I'm not including the 1 because there it's not below, it's on the x-axis. Now, for the next example, let me get rid of my highlighted portions here. For the next example, part C, it's asking for above or on. So again, using my highlighter, all of this is above, this is on, this is on. So these are the three pieces that I need then. And so this is going to be from negative infinity up to 0, and we're going to include that 0. And then we're just going to use listing notation for that second part of that because there's only one value there. So I'm not using interval notation on the second piece, just listing notation. All right. I'm also asked, I forgot about this one, part D, I'm asked for the below or on. So once again, let me get rid here of my highlighted pieces. So I want below or on. So my below pieces, this is a below piece, this is a below piece, this is an on, this is an on. All right, so now as I uncover here my solutions, I'm starting at 0, and then I have no breaks all the way through to positive infinity. No breaks at all. So even at 1, it's not going to be a break there. All right, let's go into example number 3. The first thing that I'm going to do on this one is I'm going to simply rearrange my equation. So you notice I don't have 0 on one side. So the first thing I want to do is I want to get 0 on one side. Now, honestly, on this one, you could use the graphing calculator. I'm going to walk you through what we did in section 3.5 just to remind you of how to graph without a calculator on these. And so the choice is yours on this one. So you notice that what I'm looking at here is that the first thing I want is my end behavior. Well, both ends are going to be up because of the leading coefficient and the degree. My list of possibles, remember I get this from the factors of the constant divided by the factors of the leading coefficient. I would go ahead and graph it on my calculator anyway to match. If I was told not to just graph on the calculator, then I would use synthetic substitution. And so using synthetic substitution, I'm going to have an x-intercept at 1, an x-intercept at 3. Again, a lot of this work is not necessary, folks. And then I'm going to take my quadratic and I'm going to solve. And so when I solve, I'm going to have an x equals negative 1/3 with a multiplicity of 2. My y-intercept is going to occur at 0, 3. So you'll notice that on my graph, I've got my, I have my negative 1/3, my x equals 1, and my x equals 3 are all already on my graph, my 3 zeros. And it's actually 4 because one of them is a duplicate. And I also have my y-intercept. Now, when I use my end behavior, I'm starting at the top, I'm ending at the top. That first 0 that I come to is going to be a bouncer because there's 2 of them. You're going to come back through the y-intercept, break through the next 0, break through the next 0, and you have your graph. All right, so my solution, notice if you'll go back up to the original equation, we want to know where is my graph less than or equal to 0, below or on the x-axis, below or on the x-axis. So let me get my highlighter out. Here is an on, here is an on, here is a below, here is an on. So I want all the places that are below or on. So that first one, I'm just going to list it because there's only one value there. And for the second one, I'm going to start at 1 and end at 3, including both of those values. All right, for a rational inequality, what we're looking at here, this one is just as easy to graph on paper as it is to graph on the calculator. So, and it gives us some good practice of what we did in previous sections. So my vertical asymptote occurs at x equals 1. Remember, that's what makes the bottom 0. Horizontal asymptote is where I use degrees. So that's going to be y equals 1. If this is confusing to you, go back and watch the videos that I gave for section 3.5. My y-intercept, when I plug in 0 for x, I get a -3 out. Notice that's already on my graph. My x-intercept is going to occur at -3, 0, whatever makes the top 0. All right, so at this point then, I have my asymptotes on the graph. I have my x and y intercepts on the graph. When I put it into the calculator to graph the curves, remember that you are using the asymptotes as fences. And so this is what we're looking at. And now I'm being asked for everything that is above the x-axis or on the x-axis. So this piece is above, this little guy is on. All of this is above. So then when I give my solution to that, I'm going to start at -infinity and go up to -3, including -3. And then the second piece is going to be 1 to infinity, but because 1 is a vertical asymptote, I will not be including the value of 1.